Example 1 says to state the domain and range for the following relations, then determine whether the relation represents a function. So here we have 1, 2, 3, 4, 5 different ordered pairs. The first thing that we need to list here is my domain. Now, if I go back up to the top here, my domain is represented by my x values. So in ordered pairs, this is always x, comma, y. So I want to list every x value, which is the first number in each of these ordered pairs. So my domain, we're going to start with some fancy squiggly brackets like we have right here. And I'm going to list all of these x values. We have 4, 5, -3, -5, and 9. And then we will end it with our fancy squiggly brackets. So my domain was all of my x values there. So now my range, if we go back up to the top, range has to do with our y values. So my y values are all of these second numbers in these ordered pairs. So now I'm going to list all of those numbers. So we start this with our fancy squiggly brackets. We have 7, 6, 8. Now we have another 8 here. I already have 8 in this solution set, so I'm not going to write 8 again. So then we'll have 0. Okay, and end it with your fancy squiggly brackets. Now notice that my domain has 5 numbers, my range has 4 numbers, and sometimes they're not going to match. It is possible that they match, but they're not always going to match. And also notice I didn't list these from least to greatest. You can if you would like to, but when you have individual numbers, it's not necessary. So is this a function? We need to circle yes or no. If we come back up here, a function is defined by if your x does not repeat, if we have one input value. So here, looking at all of these blue numbers here, none of them repeat. We have 4, 5, -3, -8, and 9. So yes, this is a function. Why is it a function? Because our x's don't repeat. Okay, so it does not matter here that my y's repeated. My y's can repeat, my y's can cheat. I only care about those input values, those x values. Because my x does not repeat, then yes, it is a function.